Chunkers. Today we are going to work on lesson 8-9, perfect squares, and we are going to be determining if a trinomial is a perfect square. To do this, we have to use three questions. Perfect square trinomial. I want to determine if 16x squared plus 24x plus 9 is a perfect square trinomial. So I'm going to ask myself three questions. Now, it may be a good idea to put this in your notes. Is the first term a perfect square? Is the last term a perfect square? Is the middle term twice the product of the square roots of the first and third term? Now, what does that mean? Well, let's think about it. We're going to take the square root of the first term, then we're going to take the square root of the third term, and then we're going to multiply those by 2. So let's do that. So we know that the square root of 16 is 4. And we know that the square root of 9 is 3. So 4 times 3 is 12. Okay, so now it says twice the product, here's my product, of the square roots. Now, I have only multiplied it one time. So it says twice. So now I have to multiply this by 2, and that gives me 24. And then I see if that matches this middle term. And if it does, then it is a perfect square trinomial. Now we want to decide if this trinomial is a perfect square trinomial. So write down 4y squared plus 12y plus 9. So let's see if this is a perfect square trinomial. So what is the square of 4? 2. What is the square of 9? 3. It says to use the product. So 2 times 3 would give me 6. And then I need twice the product. And 6 times 2 is 12. And that does give me my middle term. So I know that this is a perfect square trinomial. So now we can write this as a perfect square. To do that, I would say 2y plus 3. And this would be squared. Okay, let's look at another trinomial. Now I have 9x squared plus 6x minus 4. The square root of 9, so the square root of 9 is 3. We're going to multiply it by the square root of 4, which is 2. That would give me 6. And 6 times 2 is 12. This is not a perfect square trinomial. So your answer would be no. Okay, I have I have two trinomials. We don't know yet if they're perfect trinomial squares. But I have two trinomials here, and I want to determine if they're perfect squares. Okay, so let's follow our rules. Now, I've erased the rules. You should have the rules in your notebook, okay, or on the side or in your examples. So the square root of 9 is 3 times the square root of 16 is 4, and 3 times 4 is 12. And if I multiply that by 2, then I get 24. So my answer is yes. This is a perfect square trinomial. Now let's look at this one over here. Well, to start with, 2, we cannot take the square root of 2. So this is an automatic no. So this is not a perfect square trinomial. Now I have two problems that I would like for you to write down, pause the video, work them, decide if they are a perfect square trinomial, then turn back on the video and watch to see if your answers are correct. Okay, let's check our answers. We want to know if this is a perfect square trinomial. Well, the square root of 25 is 5. I'm going to multiply by the square root of 36, which is 6. 5 times 6 is 30. And if I multiply that by 2, then I do get 60. So yes, this is a perfect square trinomial. Now let's look over here. What is the square root of 6? Well, I already have a problem. There is no square root of 6. Well, there technically is, but not a perfect square. So this is no. Now we are going to talk about some factoring methods that we have already learned and that we have just learned that we can use to factor polynomials and trinomials. So the factoring methods that we are going to use, one, we're going to factor out the GCL. If it has any kind of greatest common factor, we're going to pull that out of our trinomial. Two, we're going to check for a difference of squares or a perfect square trinomial. And thirdly, we're going to apply the factoring patterns for x squared plus bx plus c or ax squared plus bx plus c. For general trinomials or factor by grouping. Now you're going to want to take a minute and write these rules down in your notes. So pause the video, write these notes down, and then come back and we will work some problems. Okay, we have some examples here, and we want to factor each polynomial if possible. If the polynomial cannot be factored, then of course we're going to write prime. So let's look at 5x squared plus 80. The first thing that I see is that we can factor out a greatest common factor. And my greatest common factor is 5, which would leave me with x squared minus 16. Then I see here that I have the difference of a square. Difference of a square. So then I know that it's 5 times x plus 4 times x minus 4. And now I have factored this polynomial. Alright, let's move over to this polynomial. And again, the first thing I see is that I can factor out the greatest common factor, which is 2, leaving me with x squared minus 16. Again, I have a difference of a square, which would be 2 times x plus 4 times x minus 4. So now I have factored this polynomial completely. Okay, let's look here. So the first thing that I want to do is see if I have a greatest common factor, and I do not see one in this problem. I need to check to see if I have a difference of a square. I need to check to see if I have a perfect square trinomial. You cannot take a perfect square root out of 12. So now I'm just going to go by general factoring. So I'm going to say 12 times 25. And 12 times 25 is going to give me 300. So now I know that I have got to figure out some factors for 300. All right, so 1 times 300, 2 times 150, 3 times 100, 4 times 75. Now remember, I am looking for two numbers that when I subtract them, I'm going to get 5. So far I have not found that. 5 times 60, 6 times 50, 10 times 30, 12 times 15, and then right here I have found what I am looking for. Okay, sorry about that. This should be 20 times 15. Now I have found what I am looking for. So 20 times 15 would give me 300, not 12 times 15. Okay? So now I can use my general factoring rules. So I'm going to use 12x squared minus 15x plus 20x, which I'm getting from here, minus 25. Now I can factor. Here I can factor out a 3x, leaving me with 4x minus 5, plus I could take out a 5, leaving me with 4x minus 5, and then I just have to group them together. 3x plus 5 times 4x minus 5. Okay, now I have 4 polynomials, trinomials up here that I would like for you to factor. Remember to use all of your factoring methods. Pause the video and then come back and see if you got them correct. 2x squared minus x minus 28. 4x squared plus 64. 6x squared minus 34x plus 48. 4x squared plus 9x minus 16. Welcome back. Let's go over these together. Okay, well, let's work these together and you can check your answers. So let's look at the first one, 2x squared minus x minus 28. We see that 2 is not a perfect square root. We do not have a difference of a square. So we are going to have to factor using general. So 2 times 28 would give me 56. And then I need to find 2 factors of 56 that when I subtract them, I'm going to get a negative 1. So I'm going to use 8 times 7 because 8 minus 1, 8 minus 7 would give me 1. So I'm going to pair them together over here. 2x squared plus 7x plus negative 8x minus 28. Over here I'm going to pull out an x, leaving me with 2x plus 7. And then I'm going to take out a negative 4, which would leave me 2x plus 7. And then I group them together, x minus 4 times 2x plus 7, and then I have factored this polynomial completely. All right, let's come over here and let's look at 4x squared plus 64. So I'm going to take out a 4, which would leave me with x squared plus 16. And then that is now factored completely. Okay, let's look here. And I do not see the greatest common factor, perfect square. So let's see. We're going to have to say 6 times 48. Well, before we do that, you could take out a 2, which would leave you with 3x squared plus 17x plus 24. Now we're going to use our general factoring method. 24 times 3, which would give me 72. Now I'm looking for 2 numbers or 2 factors that I can multiply together and get 17. So that would be 9 times 8, and 8 plus 9 would give me my 17. So I'm going to break it into 3x squared. I'm going to put it with the 9 plus 9. Plus 8x plus 24, and then I can factor out a 3, which would give me 3 plus 3x plus 3. Let's start over. Okay, I'm going to take out a 3x, which would give me x plus 3. And then over here, I'm going to pull out an 8, which would give me x plus 3. Then that's going to give me 2 times the 3x plus 8 times x plus 3. And that would be factored completely. Okay, over here I'm going to check for greatest common factor. No. For a perfect square, well, the perfect square, a square root of 4 would be 2. Square root of 16 would be 4. If you multiply those together, you get 8. But 8 times 2 is 16. So no, that is not a perfect square trinomial. No. So I'm going to use general factoring. And 16 times 4 is 64. And I need 2 factors that would give me 9 when subtracted. So I have 1 and 64. That will not work. I have 2 and 32. That will not work. 4 and 16. No. And 8 times 8. So no, we cannot factor this. So this one is prime.